Hello everyone, welcome to Learn ReactJS for Frontend Development by CodeChef. In today's lesson, we'll be looking at an important React concept, which is side effects, and how we can use the useEffect hook to manage them. Side effects includes things like updating the page title, fetching data from API, and working with event listeners. These actions happen outside the normal rendering process and are most commonly used in React applications. So in this lesson, we'll be looking at what side effects are, why they matter, and how we can use the useEffect hook to manage them. So let's begin. In this lesson, we'll understand what side effects are in React and how we manage them using the useEffect hook. This concept is extremely important because most real-world React applications rely on side effects. A side effect is any action that happens outside the normal rendering of a component. For example, calling an API, updating the document title, adding event listeners, or starting timers. These actions don't directly return the user interface, but they affect the application. React provides the useEffect hook to handle side effects inside functional components. It allows us to run code after the component renders and keeps the side effect logic separate from the rendering logic. So this is the basic syntax of useEffect. The function inside it runs after the component renders. Any side effect code like API calls or DOM updates goes inside this function. When we don't pass a dependency array, the effect runs after every render. This means any state update or re-render will trigger the effect again. The dependency array lets us control when the effect runs. An empty array means it runs only once when the component mounts. Passing a variable means the effect runs only when the variable changes. Some side effects need cleanup, like timers or event listeners. useEffect allows us to return a cleanup function which runs when the component unmounts or before the effect runs again. Common mistakes include forgetting dependencies, not cleaning up effects, or using stale state values. These can lead to bugs, memory leaks, or unexpected behavior. To summarize this, useEffect is used for side effects, dependency array controls when the effect runs, and the cleanup functions keep your app stable and efficient. So let us look at side effects and the useEffect hook. First, let's start with the code that's already written in the IDE. We import useState and useEffect from React. Inside the component, we create a state variable called count. This value increases every time we click the button. Now look at the useEffect block. Inside it, we update the browser's page title using the current value of count. Now let's just run this code once. So let me just open this application on a new tab. So let's just click this button a couple of times. Now you will notice two things. One, the number on the screen increases as soon as we click on the button. And the second point, which is important, that the page title also changes. So you can see, let's say I click 2 more times, you can see over here it's getting updated. So what's happening here is that React renders the UI first, and then after that useEffect runs and updates the title. Now notice something important. We didn't tell React when this effect should run. So React runs it after every render by default. Every button click causes a state change, a re-render, and then useEffect runs again. Now sometimes running an effect after every render is unnecessary or inefficient, so React gives us a way to control when an effect runs. We do this using something called a dependency array. The dependency array is simply a list of values that the effect depends on. Now let us see how we can run the effect only once. Now here, we pass an empty array as a second argument. This empty array tells React, this effect does not depend on any changing value. So React runs this effect only once when the component appears on the screen for the first time. Now let us look at how we can run the effect when a value changes. Now we put count inside the dependency array. This tells React only run this effect when count changes. If the component re-renders for any other reason, this effect will not run. In our previous example, we didn't use a dependency array, so the effect runs after every render. Now further in this video, we'll learn how to optimize that by adding dependencies when needed. Now let us see how we can fetch data with useEffect hook. This is a common real-world use of useEffect. We fetch data from an API when the component loads. We use an empty dependency array because we only want this API call to happen once, not on every render. First, the UI shows a loading message. Once the data arrives, state updates and the UI re-renders. So let us look at autofocusing and input using useref and useEffect hook. So in the code given over here, first we create a reference using useref null. This reference will later point to the actual input element in the DOM. We attach this reference to the input using ref equal input ref. Now look at the useEffect. Inside it, we call input_ref.current.focus because we pass an empty dependency array, and this effect runs only once, right after the component renders. So when the component loads, React renders the input first and then useEffect runs and focuses the input field. So why not use HTML autofocus? This approach works better than using the HTML autofocus attribute. React components often render after the page loads, so autofocus may not work reliably. Using useRef and useEffect hooks ensure the focus happens at the correct time after React finishes rendering. Now let us look at tracking mouse position using useEffect. In this example, first we start by creating a state called position that stores the mouse's x and y coordinates. Inside useEffect, we define a function called handleMove. This function runs whenever the mouse moves and updates the state using the events client x and client y values. Then, we attach this function as a global event listener using window.addEventListener. Because the dependency array is empty, this event listener is added only once when the component mounts. Every time the mouse moves, the state updates and the UI re-renders to show the new cursor position. This is a common pattern when working with global event listeners. The event listener itself is a side effect, so it belongs inside useEffect. Also, whenever we add global listeners like this, we should always remember to clean them up, which we'll cover in the next section. So let's just run this code once. So you can see the mouse tracker is tracking the position of our cursor. So let us now understand cleanup in React. First, let's focus on this useEffect block. Here, we create a timer using setInterval that increments the count every second. Because the dependency array is empty, this effect runs once when the component mounts and starts the timer. However, notice that there is no cleanup function here. So, when the component is removed from the screen, the timer keeps running in the background. So why is this a problem? When the component unmounts, React removes the user interface, but the timer is still active. This causes two issues. The timer continues to consume memory, and it may try to update state on a component that no longer exists. This is why cleanup is required when using timers or event listeners. So let us add a cleanup function to this particular code. Now let us look at this fixed version. Inside useEffect, after starting the timer, we return a function. This return function is the cleanup function. Inside it, we call clearInterval using the same timer ID. This tells React how to clean up the side effect when it's no longer needed. This cleanup function runs automatically in two cases. First, when the component unmounts, for example, when we hide the timer by clicking the button. Second, before the effect runs again, if the dependencies ever change. In this case, since the dependency array is empty, cleanup only runs once the component unmounts. So let us look at the timer component as a whole. The timer starts when the component mounts. When the component is removed, React automatically runs the cleanup function and stops the timer. This prevents memory leaks and keeps the application stable. So let's just run this code once. So you can see we can toggle timer using this button. So let us understand stale values in React. Let's start by focusing on this useEffect. Inside the effect, we define a handleKeyPress function that listens for the L key and toggles the light using setIsOn! !Is_on. The important thing to notice is the empty dependency array at the end. Because of this, the effect runs only once, when the component mounts. At that time, isOn is false, and this value gets captured inside the handleKeyPress function. So why does the value become stale? Even when the state updates later, this handleKeyPress function still remembers the old value of isOn. So the first time we press L key, it works, but after that the function keeps on using the old value, making the keyboard toggle feel broken. This is what we call a stale value. The function is using an outdated state. So let us look at the first fix. Here, we add isOn to the dependency array. This means the effect reruns every time isOn changes. Each time the effect runs, a new handleKeyPress function is created with the latest value of isOn. So now, both the button and the keyboard shortcut work correctly. The downside of this approach is that the event listener is removed and added again every time isOn changes. This is usually fine, but it can be slightly inefficient if the effect runs very often. Now let us look at the second fix. Instead of using setIsOn! !Is_on, here we use the functional update form. Now let us look at the second fix. Instead of using setIsOn! !Is_on, we use the functional update form. Here, React passes the latest stale value into the updater function as current. This means the function always gets the most recent value, even though the effect itself runs only once. Now let's see why the second fix works better. This approach avoids stale values completely. The event listener is added only once, and React ensures the state update always uses the latest value. This is usually the best solution for event listeners and timers. So let's just run this code once. So you can see as soon as I click the L key, the toggle button is working. So let us understand debouncing with the useEffect hook. The component already has an input field to type a movie name, a list to display filtered movies, and a state to store the search text and the filtered results. What's missing is the logic that updates the movie list when the user types. The useEffect is already present, but it's empty. This is where we'll add our filtering logic. So let's first understand what happens without debouncing. If you filter the movie list directly every time the user types a letter, the filtering runs on every keystroke. For example, typing matrix triggers filtering multiple times, that is whenever you type M, MA, MAT and so on. This makes the app feel jittery and does unnecessary work. So to fix this, we use a technique called debouncing. Debouncing means wait for the user to stop typing and then perform the action. In our case, we wait 500 milliseconds after typing stops before filtering the movies. Let's now go through this effect step by step. First, we pass search query inside the dependency array. This tells React to run this effect every time the user types something. Inside the effect, we create a timer using setTimeout. This timer waits for 500 milliseconds before running the filtering logic. Inside the timer, we filter the movies array. We check if movie name includes the search text, and then we update the filter movie state. Now look at the cleanup function. If the user types again before 500 milliseconds pass, React runs the cleanup first. This clears the previous timer and starts a new one. Because of this, old timers don't run, and only the last input triggers filtering. This is what makes debouncing work. So because of this, from the user's perspective, typing feels smooth, filtering happens only after a short pause, and UI updates cleanly without the unnecessary re-renders. So let's just run this code once. So in this movie list, let's say I search for Goodfellas and I type GOOD. So you can see it is filtering according to the letters I've typed, and it is waiting 500 milliseconds before resetting the timer. So that wraps up our introduction to side effects in React. To really understand this concept, make sure to head over to the CodeChef platform and try out the practice problems yourself. That's where the real learning happens. So that was it for this lesson, and I'll see you in the next one. Thank you.